First of all, I have to sort of do the depressing thing first and just outline where we're at with climate change, and sort of why well-being impacts are going to be arriving earlier than we thought. This is a figure that I put together with a colleague looking at the so-called burning ember plots of IPCC reports through the years. So on the left you've got the third assessment report, and on the right you've got assessment report 6. And so this spans about 2 decades. And what this shows for different types of impacts, so on the left sort of block, we've got the aggregate impacts on the economy and ecology. And on the right, we've got these large-scale tipping elements, these large-scale discontinuities. And what I did here was just to show how the risk of these impacts has dropped dramatically with the temperature over time. So that is, we've systemically underestimated the impact of climate change. So on the left there, you can see the things that sort of the sort of moderate risk to sort of economic and ecological impacts has dropped from just over 3 degrees to below 2 degrees. We're in the danger zone now for those aggregate impacts. And if you have a look at these large-scale tipping elements, there we've really underestimated the Earth system dynamics. And so what we thought would be happening at above 5 degrees, that's now down below 2 degrees in the more recent IPCC assessments. Now, of course, you can see that there's still that underestimation still. So there's some sort of approaching obviously we're getting close to where we are at it with those arrows. But okay. So, and what we can see actually is also this bears out on more national levels. Because you might say, well, in one case that's sort of like a large-scale scientific assessment globally. How does that play on a national level? What I've shown here is for the UK. I've shown the blue is the Climate Change Risk Assessment 1 in 2012. And the red is Climate Change Risk Assessment 3 in 2021. And what we can see here is that the numbers of high or very high risks have jumped dramatically. And so these have a specific definition of very high is at least £1 billion of losses per year for a specific risk. We're already very close to that for flooding. Flooding is the biggest issue that we have in the UK. So you can see this again. One of the remarkable facts about this is in the Climate Change Risk Assessment 3, they had a new model, and they were very proud of this model, and they said, using this new model and this new representation of this very high resolution climate model, we find that the chance of exceeding 40 degrees by 2040 is 0.02%. That was in 2021, and of course in 2022 we breached 40 degrees in both rural and in urban areas. That's no casting shade on the modelers. It's really, really hard work, but it just goes to show that we have dramatically underestimated. And coming back to this point about sort of well-being then. So one of the areas that I'm sort of most focused on at the moment and most concerned about is how this then connects through to things like inflation and volatility, and how this can affect well-being and then potentially affect your finite pool of worry and what you're sort of focusing on. So these so-called derailment risks, where we could go down a bit of a spiral here. If we're talking about food systems, I mean, it's the same story again. What we thought would happen once every 16 years in terms of a breadbasket failure in maize. So this is it's defined differently in different papers, but in this specific paper it was sort of the lowest decile of a time series. The chances of a breadbasket failure in maize once every 16 years before climate change, that goes up to once every 3 years at 1.5 degrees and once every 2 years at 2 degrees. This is the most sensitive crop, but we do see that jump between the before climate change and the 1.5 degrees there. And so you see that big jump when you get to 1.5 degrees. Of course, there's lots of things we can do about this, and a lot of mitigation effects actually, I think, have massive ramifications for well-being. I'm not going to cover that today because I'm going to go on to talk about a particular paper. But I don't want to leave you on just the really negative side of things, because basically a lot of the things that we need to do to address climate change in both energy and food systems do great things for well-being, or at least for the factors that influence well-being. This is a paper that looked at all the different. This is intentionally overwhelming. This is a paper of all the different impacts of climate change on society, and they found about 400 different interactions of climate change. So just to pick out some here, we can sort of start thinking about things like water scarcity affecting food shortages, which then impacts vector-borne diseases, like malnutrition, which can then connect to migration, displacement, conflict. Okay, so there's loads of different ways in which these can interact. And as this paper also found, the evidence of observed impacts and projected risks are worse than we thought. Okay, in fact, there's actually sort of like a tag you can look up on social media that it's worse than we thought. So if you ever do want to have a look at really negative information, just look up the tag, it's worse than we thought. So what wellbeing components are contained in these climate environment relevant policy models? So sort of largely thinking about models in the literature, but also thinking about these models that are used that are reported in the IPCC. And this is based on a paper that actually just came out last week by a PhD student, Inga Schreiber. She did a bit of a solid job on this. I'll show you in a minute. There's a lot of detail that she went through. Can I go forwards? Oh, thank you. So just before we get onto this, the types of models that people are using. And so you can start to think about where does well-being come in, where do the factors that underpin well-being come into this. The first ones are process-based integrated assessment models. These are general or partial equilibrium models. So this is based on market clearing and prices and finding balances there. Many soft links to other systems. So often you have an environmental model that's sort of soft linked into it. So it looks like something like this. You have some drivers, you have a human system, you have an earth system, and you have some impacts. The issues are there's no climate or nature feedbacks, i.e. there are no climate damages in these sorts of models, which instantly, for me, raises huge red flags. And many of the most important variables are actually specified exogenously in these models, so GDP, population, etc. So that's one type of model. Another main type of model is cost-benefit integrated models. These are sort of optimization models. You may have heard of these. So the previous ones, you might have heard of image or remind or message. It doesn't matter if you've heard of them or not, but these are the sorts of acronyms. In these cost-benefit integrated models, we're talking things like DICE, fund, page. And so these are cost optimization models. These do have a very simple feedback between GDP and warming. It's actually a quadratic, but there's been a lot, so you can see the sort of model arrangement there. But there's a lot of critiques here. This is one of my sort of favourite papers on this climate change policy. Well, you see, you've read it already. Climate change policy, what do the models tell us? Very little. And this is one of the most sort of well-cited papers on this. The last one is system dynamics models. These tend to be very simple representations of different sectors and how they might interact. But it has these feedbacks, but then it's quite hard to calibrate. It's quite hard to put more detail because every single feedback you put in makes the computation just much more complex. And so what Inga did was to go through these different models, here's a list of them, and just have a look at how do well-being factors, how are they captured in these models. So this was defined on Anna Hicker's work, so looking at 10 components, health, material, living standards. I won't read them all out, but basically a sort of a basket of different impacts that climate change can have. Then what Inga did was go through all of those and say, in the quantitative literature, are there estimates of what climate damages are to each of these sorts of different impacts? And then, are they picked up in any of these models? So are they sort of seen, as it were? And so this is where the valiant effort came in, because you can imagine there's a lot of impacts. We just saw that overwhelming figure before. This is a picture of the sort of qualitative and quantitative links between climate change hazards and different well-being outcomes. I'll just zoom into one here. So for example, you can temperature rise, impacts on adverse birth outcomes, heat-related conditions, mortality, that sort of thing. And then the next was to then have a look at how this is mapped in models. And you're probably starting to realise how big an effort this was to go through the literature. And you can see the dotted lines there. The heavier the line, the more they're represented, basically. Now they're represented in sort of different ways, but you can see these sorts of representations across these different models. And then how they might be, in some models, normally the systems dynamic models, they'll actually have HDI, for example, in them. And then what we have here, I realise this is a lot of sort of text, but yeah, I didn't, when you're looking through a paper, you go, well, I really wish we could have done a figure just in a more simple way, so but we didn't, so this is what it looks like, because I think there's just too much going in. you can see on the left-hand side here, we've got the well-being subcomponent that we were looking at, and what that colour shows is how well it's quantified in the literature. So specific assessments of that well-being subcomponent that has some assessment of climate change impacts on it. And then the colours on the right, how they're involved, how they're included in the models themselves, and to what which model was in each of those sectors. You can see that GDP is in a lot of them, of course, but many fewer of them for safety, freedom, governance, subjective well-being, etc. The models include, to some extent, in my honest opinion, I think actually quite poorly in a lot of cases, temperature-related mortality, food security, and GDP. But across most or all models, they don't include infectious diseases, respiratory, cardiovascular, and neurological outcomes, mental health, adverse birth outcomes, occupational health, and labour productivity that we were just discussing, conflict, migration, poverty, air quality, and biodiversity loss. So, these are what a lot of people would say makes life worth living. We're not seeing it in the models. Just maybe reflection on some of the studies, these are really, they do have real world outcomes and real world impacts. On the left there is another excellent critique of using these sorts of models, at least the first two classes of models that I mentioned, by Marty Weissman. When you're talking about a problem like climate change, should you be applying these? And on the right is actually a sort of an expose almost in science about how the models were selecting for bioenergy, carbon capture and sequestration to make up for the fact that the models can't really see any sort of well-being benefits or explore any sort of other dynamics other than a technological sort of end of the pipe solution, which is sucking up CO2 from the atmosphere in the second half of the century because, optimized, equilibrium models. And then I just was reminded by this earlier by and that's actually Jonathan, was, to a certain extent, sort of commentators are making real world damage here as well with Bill Gates's recent tough truths. Fortunately for all of us, this view is wrong. Although climate change will have serious consequences, particularly for the people in the poorest countries, it will not lead to humanity's demise. People will be able to live and thrive in most places. And I find that quite remarkable, coming out just before we saw Jamaica get hit by $10 billion flood damage. I mean, Jamaica has a GDP of $20 billion, so half of its GDP wiped out with one flood that we saw. And, this comes back to this point about the acute damages versus the chronic damages. What I'm really worried about is you've got the acute damages, so you've got the sort of action on the ground and the individual impact and the community impact on the ground, but then you've also got the chronic impacts. What we were talking about earlier about the sort of food system impacts, and if you ever look at the inflationary effect of that, that can be quite dramatic. So one estimate suggests that about a third of the food price inflation that we saw during 2023 was driven by climate impacts during that year. Now, this is why the military call it a threat multiplier, of course, because it's not simply the climate change that drives it. Yes, we had Ukraine, yes, we had these other problems, but it just layers it on top in terms of really hitting societal resilience. Anyway, so I think these sorts of ideas, are not very helpful because in a lot of cases, climate action is also actually sort of well-being action. Of course, it has to be done right and done in a just way. And it, just a last reflection, is there a better way? I think system dynamics models potentially have more opportunity and potential so that you can actually more transparently model fewer relationships but do them well with the feedbacks. But also I think, the sort of aggregation and reviewing of quantitative assessments I think are important. So there's a really good report called What Will Climate Change Cost the UK? And that came up with very different numbers than any of the models. So they were talking about 7% reductions of GDP year on year by 2080. I synthesized that a little bit and added some other stuff in a report that I did on the impact of climate change on the cost of living. And also in imagination. So I also do think that, I think this is why some quantitative scientists like myself also do see a value in literature here for exploring these different futures and impacts on well-being. I've rather immodestly put my book there as well in terms of a non-fiction book. But also there's really interesting books that I think are coming out about governance and how governance sort of develops over time. Peter Turchin's book there called Enzymes. Anyway, so I'll leave it there, and happy to take questions and thoughts. Thank you.